But it's a real pleasure to be here this morning and talk with you. And yes, I do have the bad cop job this morning, but we've got other speakers like Anika Molesworth and others tomorrow to give a much add balance to this by looking at what we can do to deal with the issues ahead of us. And I'd love to thank Rebecca and IGCC for the opportunity to be here today. So what I'm talking about briefly is a real quick update in terms of the climate science. This is a massive topic. I'm doing a 10-minuter on this, and so it'll be a quick race through. But what we see happening at the moment is greenhouse gas emissions. This is the fossil fuel-based emissions on this graph, keep on going up. COVID made very little difference, is that we bounced back incredibly quickly after COVID, or at least the first year of COVID. And we then had record levels in 2021 and then record levels again in 2022. And it looks like we're going to have record levels of carbon dioxide emissions this year if we look at what's coming out of China in terms of their emissions and energy use to date this year. And because of the accumulative nature of carbon dioxide in the atmosphere, it accumulates in the atmosphere, the only way we can stop this accumulation, which has now given us concentrations of about 424 parts per million this year, it's 50% higher than it was pre-industrially, is by taking this curve down to net zero. That's the only way you can stop carbon dioxide accumulating in the atmosphere and causing additional warming, is to take it down to net zero. So that's where the net zero comes from when you hear the policy statements, net zero by 2050, etc. That's the science, it's very, very clear. You've got to take this curve from about 40 billion tonnes of carbon dioxide a year down to net zero. Now, it's not just carbon dioxide, but also methane, nitrous oxide and other greenhouse gases are at record levels of emissions and record concentrations in the atmosphere. So, for example, methane is 3 times the pre-industrial level. And of course, that we know, and we've known for a long, long time, that increased carbon dioxide, etc., in the atmosphere will warm the Earth. It's exactly what we're seeing. This is a graph from multiple temperature records across the globe. They all show the same thing, which is that temperature is accelerating. It's not just going up linearly, it's going up faster and faster over time. We anticipate this year to be one of the 3 warmest years on record. Next year will probably be again the warmest year on record. And we're likely to see that continue. That trend will continue while we have high levels of greenhouse gas emissions. Now, there's a lot of things going on as to why it's such a warm year, and we've heard a couple of times, including from the Minister Bowen, on that. One of the key ones is that we've flipped from a La Nina series of years into an El Nino year. So even though the Bureau of Meteorology hasn't actually said it's an El Nino, everyone else says it's an El Nino. And you can see from this graph over towards Peru and Bolivia, that's a big triangle of red that's coming out from South America, pointing over towards the Philippines. That's the classic El Nino signal. And that, of course, that warms the Earth, is that El Ninos tend to push up temperatures globally around about 0.2 degrees compared with what they would otherwise have been. But you can see from this map of sea surface temperatures that it's not just what's happening with El Nino that's driving the massive temperatures we're experiencing at the moment. We've got the North Pacific is incredibly hot, the North Atlantic is really hot, and the Arctic is really hot as well. And so that's why we're getting those massive temperature spikes across the Northern Hemisphere and also across parts of the Southern Hemisphere with record temperatures in parts of South America. And so we're seeing El Nino driving those temperatures up, but there's a whole range of other things as well, which I haven't got time to go into. But when we look at what's actually happening this year, each of these little wiggly lines is the month-by-month temperature for a given year. And you can see that top line is where we are for this year. So when people have said we're at record temperatures in July and June, etc., it's not just a marginal record. This is a massive, massive record. This is like, running 100 metres and going from 9 seconds down to 6 seconds. That's the type of change that we're seeing, something which is way beyond the norm. It's not incremental in its nature. It's very, very substantial. And so these are the reasons why we're seeing these big climate costs across the Northern Hemisphere particularly, and we're likely to continue experiencing those as long as we keep our foot on the climate change accelerator. So how do we take our foot off the climate change accelerator? We have to go onto one of these two bottom curves. This is a graph from the IPCC report just released earlier this year, and it shows the trajectory we need in terms of all greenhouse gas emissions if we're to keep temperatures down to 1.5 or 2 degrees. The Paris Agreement is actually around temperature goals. It's keeping temperatures in to a level which doesn't cause unnecessary human interference with the climate system. And the only way we can do that is actually reducing those greenhouse gas emissions, and we have to go on those two curves down towards the bottom of the graph, so that the one which is said limit warming to 2 degrees and the other one to 1.5. We can see in contrast, though, where we're actually heading. So the assessment of existing policies is effectively that sort of red plume of colours to the right, and that's where our existing policies head. Now, you can look at that graph, the difference between our existing policies and where we need to be to manage climate change, and you can see that as an incredible threat and a challenge, etc. Or you could look at that gap and you can see that as a massive opportunity. And there's a whole range of companies around the world who have taken that alternative view, which is that gap is a massive and huge continuing opportunity for them. And so a lot of this stuff about climate change depends on how you look at it and how you respond. You can respond in ways which emphasise the challenge, or you can respond in ways that emphasise the opportunity. So what does it look like, the world look like, if we keep going on the trajectory we're on? So this is, again, a graph from the IPCC, the Intergovernmental Panel on Climate Change. What it did was produce a temperature graph to emphasise the intergenerational equity issues of climate change. So it compared the temperatures from someone who was born in 1950 and when they're essentially 70 years old, and someone who was born just recently and who's going to live out into the future. And you can see those trajectories labelled very high down to very low. They're different greenhouse gas emission trajectories which lead to different temperatures. And you can see under all of those different emission trajectories, the temperature environment in which a child who's just born now will be massively different from that of their grandparents. And in fact, the studies on which this was based looked at this in significantly more detail, and they looked at the extreme event experience over those lifetimes. And this is a headline just to describe that study. And it says, as you can read, today's children, a child just born, will live through 3, or in fact the study showed 3 to 4 times as many extreme events on average as their grandparents did. And so something that happened to their grandparents once or twice in their life will actually become a semi-regular occurrence for a lot of people. And as you just started to see from that Lismore film, those occurrences last for a long, long time. The recovery period is extraordinary these days from these big events. And that means that if you actually got someone who's experiencing these things 3 to 4 times as many times as their grandparents did, they will just be lurching from one disaster to the next to the next. And that's a world which I don't think we want. And equally, there's a whole stack of distributional impacts which are around poverty, about geography, about developing versus developed nation status. And so these distributional inequities are absolutely consistent right across climate change. So these two graphs that I have here, one shows heat stress under different temperature scenarios. So it's combinations of heat and humidity which make it difficult for humans to operate outside. And the other is on fisheries, a key source of protein, particularly in our region to our north. And you can see under both of those, higher temperatures generate really, really problematic outcomes for many, many people across the world. In fact, the majority of people across the world. Now, if you just look at heat stress obviously has major health impacts. It impacts on infrastructure planning, impacts on our environment. It also impacts on labour productivity. So very strong relationships between labour productivity and high temperature. So these sorts of scenarios are threats in many, many different ways. If we look at, again, just referring to that Lismore floods, the extreme floods we're experiencing those because the water cycle, the global water cycle, is accelerating much, much faster than we thought it would. So we've had good theory which goes back a long, long way, like hundreds of years, which actually says that as the world warms, it should actually get on average wetter. And that's exactly what we're seeing, but that wetness is not distributed evenly geographically, nor evenly in a temporal sense, a time-based sense. And so what we're actually seeing is that water cycle, what water goes up into the atmosphere and then comes back down, is actually accelerating at twice the speed that the global climate models would indicate, twice the speed that the theory would indicate. And so what we're actually seeing as a result is both somewhat perversely increased risk of drought in many regions and also increased risk of floods. And so that increased risk is actually related to the changes in the atmospheric capacity to hold moisture. And I can explain this more in question time if needed. But what that's doing is it's actually happening, again, faster than the models would predict. So we're getting more droughts more quickly, more seriously than the models would predict, and similarly with floods and similarly with fires. We've also seen this massive increase in rainfall intensity. So when we actually heat up the atmosphere, it's like a bucket in the atmosphere, and that bucket size grows exponentially as the temperature increases. So small increases in atmospheric warming result in big increases in the atmospheric bucket size. So when it fills up and dumps on us, that's what happens essentially when it rains, we have a much bigger bucket to dump on us. And that's why we're seeing this massive increase in rainfall intensity. And a recent study here in the Sydney Basin showed that had actually increased by about 40% over the last 2 decades because of warming in the atmosphere. So our sub-hourly rainfall intensity is increasing incredibly quickly. And that's why we're seeing these sort of flash floods across our urban systems, because of this increased rainfall intensity. We've also perversely seen increased dryness of the air, and that mightn't sound particularly substantial to a lot of people, but actually that's what drives the amount of water in our rivers, that's what drives the agricultural productivity. As the dryness of the air increases, the agricultural productivity drops for every millimetre of rain that you get. So we're seeing these things which are systemic and linked to each other, and they accumulate in some ways in our river systems, which are a function of how much rain falls and how much water gets evaporated. And we've already seen the southwest WA effectively lost about 85% of their runoff into their dams to date with climate change influences, and in the Murray it's around 40%. When I was actually listening to our ministers there, I actually took down note of the number of times they mentioned emission reduction and mitigation activities, energy transition, etc., versus the number of times they mentioned climate adaptation. It was 31 versus 2. So we're massively underdoing climate adaptation, the responses to climate, the threats we're seeing and the opportunities that we can actually generate from climate change. And so as a result that we actually have this lack of sort of policy and political attention, we're seeing a really big gap between where the sort of essentially the adaptation capacity and focus is versus where rationally it should be for good economic and policy outcomes. And so unfortunately, that gap is already there, and it's already largest amongst developing countries and with the poor people, and that's likely to continue to grow. We see that the adaptation responses are very suboptimal. So they're fragmented, they're incremental in their nature, they're very sector specific, so they're not being transferred across sectors, and they're unequally distributed. So we're seeing inequities grow because of this lack of attention on effective adaptation. Importantly, the IPCC report actually said that if we actually look out into the future and the climate scenarios we anticipate, those adaptation options which work reasonably well today will actually work less and less well in the future. So as the future changes, our current toolbox becomes less adapted or less appropriate to that future environment. So we need to invent and continue to invent new and more effective adaptation responses. We see that there's lots of reasons why there are barriers to adaptation, including private finance. So lack of private finance because there's no obvious business case in some situations. We know how to overcome those barriers in most circumstances, but we're not doing it at the moment. But when we actually look at what's happening, and Rebecca mentioned this before, is that what we actually see is mandatory reporting, which not only deals with greenhouse gas emissions, but includes how businesses deal with physical risk. And that effectively is adaptation. When you deal with your physical risk under the TCFD framework, that's adaptation. So increasingly, adaptation will just be seen as good business. And when we actually start to look at this, there's a huge number of adaptation options available, just like there's a huge number of emission reduction options available. So this is again a graph from the recent IPCC report. And on the right-hand side, it shows emission reduction options and their relative cost. And Frank Yotzo will be talking more about this tomorrow, so I won't go into that. On the left-hand side are different adaptation options, in this case just for a couple of sectors, which actually say there's a whole series of adaptation responses which we know about, which can take some of the risk out of climate change. And we know that in many cases there's good linkages between those adaptation options and those emission reduction options. So we can get congruence between those and increased value from implementing one or the other. And we also know that there's a whole series of co-benefits that can occur from these. So we can get environmental and social and other benefits. And so when we actually started to look at this in the IPCC, one of the key messages coming out of the IPCC was that action on climate change is much, much cheaper than inaction on climate change. That action on climate change saves you money, and it saves you money at every level, whether it's government, whether it's global, whether it's state, or whether it's local and community. Climate change action is the most rational thing we can do at the moment. Inaction makes absolutely no business sense. Thank you very much.